Welcome. This video introduces you to how to use the BYOB programming environment. So before you can use the environment, you will have to download it, follow instructions on my website. Once you do, and either install it or unpack the zip folder, you'll have to find the BYOB executable and open it. And once you do, you will see the programming environment we're going to work in. I'm going to start by describing the major regions that we see. Over here is the stage. This is where anything that happens in my program will play out, and where I get to see my program run. Down here at the bottom is a list of my sprites. Think of sprites as the characters in our program. So right now I have one sprite called Sprite1, and if I want I can edit him. I'm going to change his name. Sprite1 feels kind of impersonal, so we're going to call him Alonzo. That is the name that the BYOB inventors gave this odd-looking character. So he now has a name. If I want, I can go in and I can make new costumes for him. I can edit what he looks like. All kinds of fun stuff we can do. We're not necessarily going to play with all those options, but be aware that there's all kinds of fun stuff we can do that we're not doing as of yet. Now I can pick up this sprite and I can drag him around the screen to put him in a new location. I can right click him and resize the sprite or rotate it if I want to force him to be facing a different direction or to be a different size. And oftentimes I like to shrink sprites down so they don't take up quite so much space on the screen. This area, the Scripts tab, is the program that Alonzo is going to run, or any code that I want him to run. The kinds of things he can do are listed over here. So in the upper left corner there's a group of 8 tabs, and these are the kinds of instructions I can ask the character to run. So let's start with looks, say hello for 2 seconds. This is one thing he can do. And the way I tell Alonzo that I want him to do is to drag it in to this particular sprite. And then I can run it by double clicking. While it's active, you can see there's a white border around it. And I can see it's happening over here. Let's try adding another instruction. So I'm going to have him say bye. When I run that one, he says that. When I run hello, he says hello. If I want to start building a program, I have to put these instructions together. You may have noticed the instructions have kind of an odd shape and this little bump on the bottom and a hole in the top. Those are designed to show us how they snap together. When I snap these together, these two individual blocks become a group, become a larger program. He says hello for 2 seconds and then bye for 2 seconds. He's just going to execute those in order. Now they're kind of considered a block. If I pick up the first one, I'm going to move the whole thing. Let's try adding one more. So hello, then bye for 2 seconds, and then no really, go away for 2 seconds. So whatever is in this block of code, he will execute. If I want to start breaking things up, like I said, grabbing the first instruction moves the whole group. Grabbing the second one just moves those bottom two, so I can break that off and just run those two, say. So say I want to pull out the bye and just go from hello to no really, go away. Well, I'd have to break that off, and then I could do something like that. That's how I could pull an instruction out of the middle. Anywhere where there's a hole in the instruction, say hello, I can go in and edit that information. So much like I change it to bye or no really, go away, I can do the same thing. I can see that there's kind of a hole here where 2 seconds is placed. So let's go in and put something else. Hello for 4 seconds. So he says that for much longer than the bye or the no really, go away. If we give him something that doesn't make sense, so I'm trying to type in a word here, it won't even take that. I can't type letters. It knows it's supposed to get a number. Every now and then you may find a way to kind of break something and to give the program input it doesn't expect. But that input area, part of why I can actually tell is because it's oval shaped, it expects a number. This one that's square shaped, it expects a piece of text. So looking at something like this instruction, change size by 10, I can see it's got an oval, so even if it didn't have 10 in there, I know it would expect a number. Well, just another way to change how big he is instead of directly manipulating the sprite. If I give it a negative number, that's going to be how I can make him smaller. We usually have multiple ways to do things. So here I'm changing his size by a fixed amount. I could also just say set size to 33%, says in relation to his normal size, so set size 100 is make him normal sized. Set size to be 200% makes him twice as big, and you can see even if I try and run that again, it doesn't change. So we've got two different ways we can think about manipulating the size. Change the current value by something, or just jump directly to a value we want. And we'll see other instances where we can do the same thing, where we can change a value, or we can jump to a particular value. So let me shrink him back down to something more manageable. 33% seem to be reasonable. And I'm just going to pick him up and drag him over there. This is getting kind of cluttered. I want to get rid of some of this stuff. So I'm going to just drag these off to the side, and that gets rid of them. That deletes them. There is a magic cleanup, which just kind of shuffles things into the upper left corner. But I just want to clear these out completely. Now, sometimes we'll be using the look instructions to change what a sprite looks like or make them say something. The other big tab we're going to be using for now are the motion and the pen commands. So motion does what you might expect. I can tell him to move 10 steps, basically 10 pixels. You just kind of have to get a feel for how big 10 steps is versus 100 steps before we kind of run out of room. If I'm looking at Alonzo, I can figure out where he's located currently. Here's his x coordinate is 111, his y is 100. If I tell him to move another 100 steps, right, now his x is 211 because he's facing off to the right. So he's just moving along the x-axis. When my mouse moves around, I can check locations, the x and y coordinates of my mouse down there. So you can see it's going to be hard to find 0, 0 exactly, but 0, 0 is right about in the middle. Y gets bigger as you go up, smaller as you go down. X gets bigger to the right, smaller to the left. Well, basically, we're working on a normal Cartesian grid where the origin is right here. We just don't see the grid lines. So, say I want this guy to move around, do a little dance. I could ask him to move a given number of steps and then turn. I'll have him turn 30 degrees, and I can see it's going to be clockwise. And then I'll have him move 10 steps, and then I'll have him turn back so that he's facing the original way, so 30 degrees. And I'll have him move another 30 steps. Kind of hard to see what he's doing. He just seems to jump from one location to another, even though he's running all this together. Certainly bumping the numbers up would make it a little bit more obvious that he is going down and not just sideways. To get a better sense of what he's doing, we've got a couple tricks we can use. One is I can ask him to wait. So I could always insert some weights between each action so we get a chance to take a look at him and see what he's doing. So move 30 steps, turn, move 100, turn, move 30. It's one kind of crude way to just slow things down and get a better sense of what's going on. To get rid of those weights, just kind of break them back out and stitch the original instructions back together here. So if you're trying to get something to work and it's going too fast to see, just remember that you can do the weights. For movement, we've got another thing we can do. We can have him draw. You can imagine every sprite's got a pen that they carry around, and we can have them put that pen down and drag it along as they move around. So I'm going to ask Alonzo, before he starts moving, to put his pen down. And now I can see the exact path he took. If I drag him to new location and have him do this again, right, there he's going to draw it. His pen is now down, so if I tell him to go to a new location, so let's tell him to jump to, I don't know, 100, 100. All right, he's going to keep drawing. If I want him to stop drawing, well, I've got to tell him to pick his pen up. So pick the pen up, and I don't know, let's jump down to 200, negative 100. And you can see he did not draw a line behind him. To clear up the screen, there's a clear, which just clears the stage of any drawing that's been done. You may notice that we can change the color of the pen and the size of the pen, and you can play around with those. But a common recipe is, if we want to have Alonzo moving around and we want to see what's going on, we'll put the pen down, we'll have him draw, and to just make sure that we start fresh each time, it's usually a good idea to put a clear there as well. So I'll tell him to clear, put his pen down, and then draw his path. And so every time I run that chunk of code, he wipes the screen clear and then does his thing. If the character's kind of getting spun around and put in a new location and you want him to always start from the same location, you can always do what I've been doing, which is drag him back to where you want him. And you could fix his rotation if he was getting spun around by doing that. Or you can use the commands we have under the Motion tab to say something like, well, I want to make sure he's pointing in the direction 90. That's right. And you can see up is 0 degrees, right is 90, down is 180, left is negative 90. And I also want him, he is currently at negative 187, 100. I always want him to jump up to that location. Negative 187 by 100. And so now, every time I run this, he's just going to repeat, bounce back to where he normally starts for how I want him to normally start, clear the screen, put his pen down, and I'll always get the exact same output. So if you're trying to build a program and you don't want to have to keep fiddling with the character and getting him set up right each time, it makes sense to do something like this, just to clear the state and get him to a known position and then run your code.